course, network attached storage. Network attached storage serves the same function as SAN, but clients access the storage in a different way. In a NAS configuration, almost any machine that can connect to the LAN or is interconnected to the LAN through a WAN can use protocols such as NFS, CIFS and HTTP to connect to the NAS and share files. In a SAS configuration, only devices that can use the fiber channel SCSI network can access the data, so it's typically done through a server with this capability. A comparison of the two systems is shown in figure 20.15. Cloud concepts. Cloud storage locates the data on a central server, but unlike with an internal data center in a LAN, the data is accessible from anywhere and in many cases from a variety of data devices. Moreover, cloud solutions typically provide fault tolerance, a dynamic computer resource, CPU, memory, network provisioning. Cloud deployments can differ in two ways: the entity that manages the solution, the percentage of the total solution provided by the vendor. First, let's look at the options relative to the entity that manages the solution. Private cloud. This is a solution owned and managed by one company solely for that company's use. Public cloud. This is a solution provided by a third party. It offloads the details to the third party but gives up some control and can introduce security issues. Hybrid cloud. This is some combination of private and public. For example, perhaps you can only use the facilities of the provider but still manage the data yourself. Community cloud. This is a solution owned and managed by a group of organizations that create the cloud for a common purpose. There are several levels of service that can be made available through a cloud deployment. Infrastructure as a service, IaaS. The vendor provides the hardware, platform or data center, and the company installs and manages its own operating systems and application systems. Platform as a service, PaaS. The vendor provides the hardware, platform or data center and the software running on the platform. Software as a service, SaaS. The vendor provides the entire solution. This includes the operating system, infrastructure and the application. Connectivity methods. When connecting to a virtual server that is in a cloud environment, there are several ways to make this connection. Virtual private network, VPN connections. This is the most direct way to connect. An example is Amazon Web Services, AWS. Virtual private cloud, VPC, that will set up a VPN connection between your entire enterprise network and its cloud. Remote desktop. While the VPN connection connects you to the virtual network, an RDP connection can be directly to a server. If the server is Windows, then you will use the remote desktop client. If the server is Linux, then the connection will most likely be an SSH connection to the command line. File transfer protocol, FTP. The FTP server will need to be enabled on the server, and then you can use the FTP client to work at the command line. This is best when performing bulk data downloads. VMware console. This allows you to mount a local DVD drive to the virtual server. This is handy for uploading ISO or installation disks to the cloud server. Security implications considerations. While an entire book can be written on the security implications of the cloud, there are some concerns that stand above the others. Among them are these: while cloud increasingly contain valuable data, they are just as susceptible to attacks as on-premise environments. Cases such as the Salesforce.com incident in which a technician fell for a phishing attack that compromised customer passwords reminds us of this. Customers are failing to ensure that the provider keeps their data safe in multi-tenant environments. They are failing to ensure that passwords are signed, protected and changed with the same attention to detail the customer might desire. A specific standard has been developed to guide providers with respect to data privacy. Data security varies greatly from country to country, and customers have no idea where their data is located at any point in time. Relationship and cloud resources. When comparing the advantages of local and cloud environments and resources that reside in each, several things stand out. A cloud environment requires very little infrastructure investment on part of the customer, while a local environment requires investment in both the equipment and the personnel to set it up and manage it. A cloud environment can be extremely scalable at a moment's notice, while scaling a local environment either up or out requires an investment in both equipment and personnel. Investments in cloud environments involve monthly fees rather than capital expenditures as would be required in a local environment. While a local environment provides total control for the organization, a cloud takes some of the control away. While you always know where your data is in a local environment, there may be the case in a cloud and the location may change rapidly. Locating and installing equipment. When infrastructure equipment is purchased and deployed, the ultimate success of the deployment can depend on selecting the proper equipment, determining its proper location in the facility and installing it correctly. Let's look at some common data center and server room equipment and a few best practices for managing these facilities. Main distribution frame. The main distribution frame connects equipment inside plant to cables and subscriber carrier equipment outside plant. It also terminates cables that run to intermediate distribution frames distributed throughout the facility. Intermediate distribution frame. An intermediate distribution frame IDF serves as a distribution point for cables from the main distribution frame MDF to individual cables connected to equipment in areas remote from these frames. The relationship between the IDFs and the MDF is shown in figure 216. Cable management. While some parts of our network may be wireless, the lion's share of the network will be connected with cables. The cables come together in large numbers at distribution points where managing them becomes important, both to protect the integrity of the cables and to prevent overheating of the infrastructure. Devices caused by masses of unruly cable. The points of congestion typically occur at the patch panels. Patch panels terminate cables from wall or data outlets. These masses of wires that emerge from the wall in a room will probably feed to the patch panel in a cable tray. We'll talk more about soon. The critical maintenance issues of the patch panel are to ensure that cabling from the patch panel to the switch is neat, that the patch cables are as short as possible without causing stress on the cables, and that the positioning of the cabling does not impede airflow to the device, which can cause overheating. Power management. Computing equipment of all types needs clean and constant power. Power fluctuations of any sort, especially complete outages and powerful surges, are a serious matter. In this section, we'll look at power issues and devices that can be implemented to avoid or mitigate them. Power converters. Power conversion is the process of converting electrical energy from one form to another. This conversion could take several forms: AC to DC, from one voltage level to another, from one frequency to another. Power converters are devices that make these conversions, and they typically are placed in line where the energy flowing into one end is converted to another form when it exits the converter. Circuits. In situations where high availability is required, it may be advisable to provision multiple power circuits to the facility. This is sometimes called A plus B or A/B power. To provision for A plus B power, you should utilize a pair of identically sized circuits, e.g. 2 by 20 amperes. In the final analysis, even these systems can fail you in some natural disasters, so you should always have power generators as well as a final backup, UPS. All infrastructure systems and servers should be connected to an uninterrupted power supply, UPS. As described in chapter 15, a UPS can immediately supply power from a battery backup when a loss of power is detected. They provide power long enough for you to either shut the system down gracefully or turn on a power generator. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.